Hello.
Hello, very good afternoon, sir.
Good afternoon. Pranam, sir.
Pranam.
Good afternoon to all.
Pranam, sir.
Pranam.
Pranam, very,
So,
very good afternoon to all of you.
Sir, सभी गुरुजन को प्रणाम सर.
Pardon?
सभी को first of all, I express my gratitude to the Indian professor, Dr. L. Sir, our colleague, Dr. G. N. Thakur, and internal examiner of this Viva-Voce examination, head of the chemistry department, Professor Rajneesh Kumar, Department of Chemistry, Patna University, member, Professor Abhay Kumar, Professor S. Kumar, Professor Sunita ji, head of the Department of Mathematics, Professor S. B. Rai ji, Dr. Asa Kumari, our research scholars, our friends, and all the participants who are attending this in the classroom of the. Now, I welcome and express my gratitude to our external examiner, Professor G. Ashok Sahab. He is the professor, eminent professor of organic chemistry and Malia University, Hyderabad, Telangana. So, UPC PSR faculty fellow and he is a reputed scholar of organic chemistry. Sir, we welcome you in this Viva-Voce examination.
Thank you, sir.
Thank you, sir.
Thank you.
Now, in this examination, Viva-Voce examination, our research scholar, who is Premanand Kumar Bhagat, Premanand Kumar Bhagat, he is Title of thesis is Studies on Coordination Complexes of Biologically Active New Benzimidazole Derivatives. He has synthesized complexes of triazole and thiadiazole benzimidazole derivatives. He has characterized this compound and is about the microbial activities of this compound. As you know, that whole compound are antiseptic, antifungal, antiviral, antibacterial, the physiological importance of this research work is very significant. Now, I request Premanand Kumar Bhagat to take his thesis. Thank you. Thank you, sir. Sorry, sir. Yeah,
बोलिए ना रंजीत के पास है चाहे पढ़ना होगा पढ़ना भी रजिस्टर बोलो रजिस्टर लेके आ रहा आ रहा हाथ में फोन आया आज हम मराठी ध्यान रखते हैं ठीक है तो बोलिए आपका आवाज भेज दिया कैमरा आपका ले रहा नहीं कैमरा नहीं
आप उस कैमरा से दिखा दीजिएगा तो सब मुझे देख नहीं पाएंगे।
मोबाइल है मोबाइल
सुन मोबाइल मोबाइल मोबाइल
कोई अलग मोबाइल हो तो रिकॉर्डिंग कर रहे हैं
कोई मोबाइल मेरा मोबाइल दो ना। हाँ हाँ सर देखना कर रहे हैं सर।
अपनी ऐसी आईडी से हुई है ना जो आईडी है उसमें यही है ना
हाँ ठीक है।
हाँ ठीक ज्वाइन हेयर टू हाँ उसमें ज्वाइन हेयर टू
अब उसको
सभी कैमरा काम नहीं कर रहा है ठीक है अब आप कहीं पे ठीक है रोटेशन मोड
सर स्टार्ट कर रहे हैं।
में आप आइए ना उसको देखिए आइए ना कहाँ पे आपका पीपीटी
अच्छा चलो अपन परमिशन लो सर से।
Okay. Am I audible, sir? Am I audible, everyone? Okay. Yes, sir. With the permission of Dr. D. Ashok, may I proceed, sir? Yes, sir. Sir, please give permission, sir. May I proceed? मेरी आवाज नहीं जा रही? Hello, respectable Dr. D. Ashok sir, may I proceed? Am I audible, sir? Hello, sir, I am audible, sir. देखिए ना, वापस से लीजिए सर को। हाँ हाँ, दोबारा ले लीजिए सर को। हाँ. Hello, Doctor, respectable Dr. D. Ashok sir, may I proceed with your permission, sir? Hello.
Hello.
हाँ.
You can start.
Okay, sir. Thank you so much, sir. Sir, first of all, I want to introduce myself. My name is Premanand Kumar Bhagat, and I am the fellow of Dr. D. and Thakur, sir. And I want to welcome all respectable faculty. First of all, I want to welcome Dr. L.K. Misra, sir, retired professor of Patna Science College. My guide, Dr. D. N. Thakur, sir. Dr. Rajneesh Kumar, sir. Respectable Dr. Mithilesh Kumar Singh, respectable Dr. Dilip Verma sir, respectable Dr. Irsad Alam sir, respectable Dr. Sumita ma'am, respectable Dr. Rohit Singh sir, respected Dr. Abhay Kumar sir, and um, everybody, and Dr. Asa Rani ma'am, my colleagues, and everyone. I I'm going to start the presenting my Ph.D. thesis with all of your permission. Okay, uh, this is the slide of my thesis head. Okay, this is my presentation by myself, Premanand Kumar Bhagat. My topic is studies on coordination complexes of biologically active new benzimidazole derivatives. Let me introduce my topic. Benzimidazole and benzimidazole derivatives have unique imidazole nuclei which play significant role in physiological system, and has been established that imidazole and benzimidazole derivative have immense medicinal activities. Any problem? Okay. What motivated me to choose this topic? First of all, the reason is hemoglobin and myoglobin contains histidine, whose imidazole part tertiary nitrogen is coordinated to porphyrin part Fe2 atoms, which plays active part in transport of oxygen to muscle cell in physiological system. And the second reason is methyl substituted 5,6 dimethyl benzimidazole is also an important part of vitamin B12. The imidazole ring is fused in purine molecule of guanine and adenine, and this plays an active and significant role in genetic code as well as in double helix structure of DNA and RNA through hydrogen bond. Okay, why this topic is important? Okay, nowadays infection, viral and microbial disease are causing acute problem worldwide because a large number of new drug resistant microbial agents have appeared in atmosphere. A variety of clinical significant species of microorganisms have become important world problem globally. One way to fight for the global challenges, there is vital need for search of new antibiotic and to develop the new novel antimicrobial agent. So there are so many diseases in this society due to microbacteria and due to so many bacteria on which example E. coli and S. aureus on which I work, and I tested my medicine which I provide in some time. I present in some time. Okay. The simplest way of presentation, this is the basic principle of my work. This is benzimidazole formed by orthophenylene diamine. reacts with any type of acid. This is acetic acid, but we can react with formic acid, pyruvic acid, and there are so many acids to which an orthophenylene diamine react and forms benzimidazole. Let's discuss on method. Benzimidazole can be synthesized in the lab through condensation reaction between orthophenylene diamine and formic acid. Formic acid is the basic acid. We can proceed with another acid too. There is no need to react with only acid, only formic acid. Okay. The reaction is typically carried out by heating the mixture of reactants, followed by neutralization with a base to precipitate the crude benzimidazole product, which is then purified. The starting material. The starting material for the preparation of above ligand, they are synthesized, separated, and characterized. The starting material required are there are some compounds which required for my further works. First of all, carbon disulfide, thiocarbohydrazide, carbon hydrazide, carbohydrazide, pyruvic acid, acetyl benzimidazole, and benzoyl benzimidazole, phenylmethanol, lactic acid, mandelic acid, diethyl carbonate. These reagents I used to my further programs and my further reagents. Preparation of starting material for preparation of ligands. This is thiocarbohydrazide. Okay, we made in bulk these compounds. This compound we made in bulk. Okay, preparation of very important starting material thiocarbohydrazide. So first of all, we took carbon disulfide and we poured in hydrazine solution, hydrazine in a ice bath solution, in a ice bath. And ice bath, after mixing and shaking, we proceed for steam bath for at least 2 to 3 hours, or approx 2 to 3 hours. Then after distillation of approx whole night, we found the crystals of thiocarbohydrazide. Okay, it's not important that we firstly found only thiocarbohydrazide. We filtrate it again and find again and again thiocarbohydrazide. Okay, synthesis. This is my first ligand. Synthesis and characterization of 4-amino 6-methyl 3-thioxo 3,4-dihydro 1,2,4 triazine 5,2-H-on. This is my first ligand. This is a triazine. This ligand is prepared by condensation of thiocarbohydrazide with pyruvic acid. This is pyruvic acid. You can see here. This is pyruvic acid, and this is thiocarbohydrazide. And as a catalyst, we used acetic acid. This is glacial acetic acid, 99.5% purity glacial acetic acid as a catalyst. And then we find this triazine. We found this triazine. Okay. Then we go for the elemental analysis. We found carbon as a calculated carbon observed, found carbon, nitrogen, carbon, hydrogen, sulfur, nitrogen, carbon, hydrogen. We found 19.93, 35, 35.48, 35, 30.58, 3.73. These are observable value, but as a calculated, the below value is given, and it proves that the compound is almost made. Okay, without any defect, because the iodine percentage is also possible. Okay, then after we go for the it's carbon 13, carbon 13. This is DMSO peak. This DMSO peaks is vary between 35 to 45 or almost. This is methyl. This is the methyl. That methyl is present here. Carbonyl. This is we can see here. This carbon is multiple with this carbon hydrogen. Since carbon do not couple with carbon, but this carbon couple with this carbon hydrogen. Okay, and this we can see here. Okay, this carbon is presented here. Okay, then we go for PXRD. Sir, we can't explain more PXRD because I didn't work any in PXRD, but this sharp signal shows that the crystalline is perfect. Okay, the crystalline is perfectly set in the compound, and this shows here PXRD and a sharp line. Okay, this is the single crystal. Since we made single crystal and we made the single crystal XRD, SCXRD from STIC Cochin. Okay, and when we found this result, and this result is perfectly I provided here. Okay, and the second ligand I made.
Mr. Bhagat,
Yes, sir.
this ligand is known or unknown?
Sir, this ligand is unknown, sir.
Not reported so far?
Yes, sir, not reported.
But then you did not record NMR, mass, etc. Did you record mass and NMR?
Sir, we did it mass, NMR, and XRD, single crystal XRD, powder XRD, all, sir.
But you didn't show mass and NMR.
Sir, yeah, this is, sir, yeah, I'm showing, sir, mass elemental analysis.
Elemental analysis is different from mass.
Okay, sir. Sir, I did only elemental analysis because this proved that percentage of carbon, nitrogen, sulfur, and hydrogen. So it
Okay.
confirms according to me.
Mm. What
Pardon for
about
any mistake,
you
sir.
recorded C13 NMR? Why not H1 NMR?
Sir, okay, sir. Sir, first of all, this, sir, see, we found single crystal. Okay, sir. Since we found single crystal, then I did decide to go for single crystal XRD, and since find success in single crystal XRD, then since I ignored 1H NMR.
Okay.
Okay, sir. Sir, we proceed on my second preparation of 2-benzimidazole, 2-yle ethylidene thiosemicarbazide. Yes, sir. The compound 2-benzimidazole, 2-yle ethylidene thiosemicarbazide was prepared by heating the condensing 2-acetyl benzimidazole with thiosemicarbazide in molar proportion of 2:1, containing glacial acetic as usual as catalyst. So this is the reaction. This is acetyl benzimidazole, and this is thiosemi. This is not This is not thiocarbazide. This is thiosemicarbazide because one NS2 is absent here. Okay, this NS2 and C double bond O. This NS2 and C double bond O react and release water and form this product. Okay. Then after we go for elemental analysis, we find the carbon percentage, nitrogen percentage, hydrogen percentage, sulfur percentage in a proper manner, and it's almost match. And then we proceed for further solubility. So we find solubility. It is partly soluble in chloroform, partly soluble in methanol, and fully soluble in DMSO. Sir, I did this work by myself. This is methanol. This is my compound in methanol, and it's clearly look wise that it's partly soluble. This is me in Dr. Hari Singh God lab, Sagar, and I did this sample by myself. Okay, sir. This I
Mr.
Yes, sir.
Bhagat,
Yes, sir.
myself means what?
Sir, Dr. K.K. Day and Dr.
No,
Puspal
no,
Ghosh, Dr. Hari Singh
no.
God University, Sagar.
You are saying that this work is done by myself. It is
Sir,
your work you are supposed to do.
yes, sir. Sir, actually, this instrumentation done by me, sir. I'm trying to say that this
Because
instrumentation
as
is
it
done
is
by me,
your
sir.
work, you are supposed to do. Who will do it?
No, sir.
This is
Actually,
your
sir,
work. You will do.
yes, sir. Actually, we are sending samples to different sir, labs,
No,
but
that is okay.
in
For
this lab,
analysis,
I
we
did
can
this
send to
work.
different places.
Yes, sir. So because
Experimental,
there,
what
yes, sir.
you are supposed to do.
Yes, actually there are no different machines are present in my college, so we
Okay,
have to send our samples to different universities and
that is okay.
different labs.
That is
So,
okay. Proceed.
Dr. KK Day and Dr. Puspal Ghosh allowed me to work in physics NMR lab. Okay, on the recommendation of my guide Dr. D. N. Thakur sir, and he provided everything to me, and then I did my all NMR work in this lab. Even I did NMR in on the work in the lab of Dr. Kalpatru Das.
Hmm.
Okay, sir.
Okay.
Yes, sir. Sir, this is the NMR 1H NMR of my sample. Sir, we can show, sir, this is first of all presence of nitrogen. Sir, NH is very difficult to present, but sir, the nitrogen have the peak chemical shift from 0.5 ppm to 15 ppm. But its identity is that presence of a very broad peak, because nitrogen react with D2 and give an exchange reaction, so that nitrogen present a complex and a broad peak. And there are nitrogen have three types of peak. NH2 present two peaks due to different stretching frequency. NH have one, and triple bond N have no one. Since no hydrogen, then there is no H anymore. Okay, sir. This is, you can ask any question.
Have you recorded DTO exchange NMR?
Sir, D2 exchange NMR. Sir, due to exchange NMR, sir, this NH shows a broad peak,
No,
according to my
have
knowledge.
you recorded D2O exchange H1NMR?
Sir, the D2O is present, deuterium is present in so many form, either in DMSO. For example, sir, this sample is done in DMSO. Okay, sir, this is not in methanol, not in
That is
chloroform.
okay.
Yeah, sir, this is
My
present in
question is,
DMSO.
have you recorded H1NMR in D2O exchange?
I think no, sir.
Okay, proceed.
Yes, sir. Sir, there is peak of -2, sir. Here is a peak showing that -2 and -2 chemical shift. And sir, this is not my fault, sir. This is -2. You can see, sir. Just one second. This is, sir. This is -1 and -2 chemical shift showing here. Sir, this
Uh,
is the region of referencing or
Due to what?
calibration issue, sir, and phase problem of baseline. This is not my problem, sir. This is not due to me. This is problem of that machine, sir. That machine have wrong baseline and calibration issue, due to which a peak on -2 and -1 came out, sir. This is not my fault, sir.
But what about integration? There is no integration.
Sir, we can do it, sir.
No, in NMR, there is no integration.
So just one second, sir. Sir, we can integrate here, sir, and also the, sir. Sir, any question, sir?
What is this one and what is this one and previous one?
Sir, this is Delta software, sir, to present 1H NMR, this is the samples, and that sample I present in that compound in my thesis. This is the compound, sir.
Previously you said -2, but here there is no -2.
Okay, sir. Okay, sir. Okay, sir. No, sir. Since you said about integration, sir, so that I come here, sir.
Okay, proceed. Proceed.
Yes, sir. Sir, this is E. coli. Yes, sir. E. coli bacteria at the sample concentration S1 and S2 using culture medium MHA, Miller Hilton agar to grow bacteria. This is MHA. Okay, this is also done by me in Dr. Hari Singh Gaur lab of microbacteria under Dr. Ujjwal, sir. Okay. So this is sir E. coli bacteria. So this is the same bacteria sprayed some time before in Mahakumbh. So this bacteria is create problem water diarrhea, low fever, loss of appetite, nausea, vomiting, stomach pain and cramps, fatigue, and it's major issue on genital organ of person, sir. Okay, sorry, sir. This have the major issue on major effect on genital organ, and I did over it. Okay, sir. I will show the result of this, sir, after during some time. This is my next ligand. So this is my next ligand, preparation of new ligand, morpholine and thiocarbohydrazide acetyl acetonate. So, the compound morpholine and thiocarbohydrazide acetyl acetone was prepared by heating then condensing acetyl acetone, morpholine and thiocarbohydrazide with thiosemicarbazide in molar proportion of 2:1 containing glacial acetic acid as catalyst. Again, sir, glacial acetic acid 99.9%, pure acetic acid. So this is soluble in all chloroform, methanol, DMSO because there is no any benzene ring, I think. So it's easily soluble in chloroform, methanol and DMSO. So I did this sample with chloroform, not with DMSO, because DMSO is so expensive for any lab, and methanol is also expensive, 25,000 rupees almost for 25 to 30 ml sample. So I did it with chloroform solution, chloroform, not solution, chloroform CDCl3. Okay, sir, this is 1H NMR. Sir, you can see presence of NH at same chemical sheet 5. Here this is TMS, tetramethylsilane, and sir all you have present. You can ask anything, sir. This,
But here also there is no integration.
okay, sorry, sir. I will next time. I prepare my NMR graph with integration, sir.
Okay, proceed.
Yes, sir. Sir, this is 13 CNMR. Sir, sir, this you can see here, sir. CDCl3 presence of CDCl3 is also 65 to 75. In this range, CDCl3 shows its peak, and this is the peak of CDCl3, and there are all carbons present here. Yes, sir. There are all carbon are present here, sir. Yes, sir. This is next ligand, sir. The name of this ligand is, sir, I noted down it. So this is bis 2-acetyl benzimidazole 2-yl N-dash thiocarbohydrazone. Okay, sir. This is the ligand I prepared. This compound is prepared by condensing 2-acetyl benzimidazole with carbothiohydrazide in ethanol and glacial acetic acid as catalyst. So this is the reaction. In previous reaction, we used semi-thiocarbazide, but here we use complete thiocarbazide, not semi. Okay, sir. This is benzimidazole, and this is the reaction because there is two molecules are present, one from this side and another from this side, or the product is complete, sir. This is the product, and also use 99% acetic acid. Its solubility is this, sir. This is very unique that this is soluble in all the solvent, chloroform, methanol, DMSO, because the generally benzimidazole is not soluble in chloroform and methanol. But since it have two benzimidazole, this have two benzimidazole and two methyl also, so that it's soluble in chloroform and methanol also, not only in DMSO, because DMSO is so expensive. So it's soluble in chloroform and methanol also, and it provides me very support because chloroform is cheap other than methanol and DMSO. So this is the 1H NMR of this sample. This is this ligand. So once again, this is nitrogen, presence of NH, and sir, this is TMS. Yes, sir. Sir, it's CHN for analysis. We did CHN analysis: percentage carbon, percentage nitrogen, percentage hydrogen, percentage sulfur. It's calculated and experimental are almost same. Its molecular formula 390, and it molecular. Yes, sir. Its molecular mass 390, and its molecular formula C19N8H18S. Sir, next ligand is synthesis and characterization of E411H benzo D-imidazole 2-yl ethylidene amino 3-mercapto 6-methyl 1,2,4 triazine 5,4H on. Okay, sir. And just we change this methyl and they replace this methyl with benzene, and found where our next ligand where only C6H5 is replaced. Okay, here is C6H5 present and here is CS3 present, and these both are different ligands. Its preparation: about 1 millimole of metal chloride was dissolved in 20 ml of hot methanol and treated with stirring 2 millimole of ligand dissolving in 25-30 ml hot methanol. The resulting solution were refluxed on a steam bath and pH was raised to 7 to 8. Sir, it's very important to raise its pH because, sir, this have lone pairs, sir. And if acidic medium is present, then this nitrogen react with H plus, and our structure goes spoil. Okay, so to remove this problem, we use ammonia, diluted ammonia, and dilute this compound so that our basic strength got increased and the presence and the chance of this nitrogen to accept hydrogen plus. Yes, sir. Sir, the precipitate complexes were digested to steam bath 60-65 degrees centigrade on the steam bath for 20 minutes and cooled at room temperature with stirring. The separate complexes were collected on Buckner funnel washed with cold methanol and ether. The separated and filtered complexes were dried. Sir, इसके preparation में दो, sir, these are two types of ligand, ML1, and sir, this is the complex formation, sir. Metal zinc, we have thick metal zinc, cadmium, we form its complex. Yes, sir. Sir, about 1 millimole of metal acetate was dissolved in 20-25 ml aqueous methanol and treated with 2 millimole of respective ligand dissolved in 30 ml hot methanol.
Don't
sir,
read. Don't
yes,
read. Just to
yes,
explain.
Yes, sir, I'm going to explain. Sir, first of all, we take 20-25 ml metal acetate, 1 millimole of metal acetate, and it dissolved in 20-25 ml hot aqueous methanol and treated with 2 millimole of respective ligand. So first of all, we took metal acetate, aqueous methanol, yes sir, and respective ligand, and dissolved in 30 ml hot methanol with constant, and then stir it after some for 30-35 minutes. Then refluxing solution we reflux to steam bath, and we took it on steam bath 60 to 65 degrees centigrade temperature. Maintaining is mandatory, otherwise the compound break down for 20 minutes. When cream yellow or light yellow complexes were separated and that means precipitated, the complex were collected on a Buckner funnel, washed and methanol, and finally with ether. The ether dried samples were dried in vacuum desiccator. We use vacuum desiccator in our college, sir, and in vacuum desiccator we try to dehydrate the sample. And the most important thing is its yield is 96 to 98% yield. Sir, this is CHNS analysis, sir. As you can see, sir, it's not need. I think it's not needed to read word by word. So these are ligands, sir, with copper, with cobalt, with nickel. This is the ligand L1, and these are complexes. And we found metal, percentage nitrogen, percentage carbon, percentage hydrogen observed and calculated form. As we found this almost with some error fraction, we found almost real image. So then we find the solubility and electrical conductance for the value of complexes in DMF. Sir, we tried to find that this complex, the complex we made, these are soluble, its solubility, its conductivity. Okay, sir, because we have to confirm that this compound is non-conductive or conductive. So we found our compounds non-conductive because the value we can see, sir, electrical conductance in per ohm per mole per centimeter square. We found 30, 35, 8, 11, and these all are below 50 to 60 range. And it confirms that these ligands and complexes are non-conducting in nature. So then we go for complexes, magnetic moment of the complexes. Okay, so then we found their magnetic moment at a different portion, different temperature, sir. And so we found this color. So then we go for electronic band position and electronic band position. We found, sir, different type of excitation, sigma to sigma star, pi to pi star, pi to pi star, n to pi star. Such since we can see, sir, there are so many pi bond, lone pair, sigma bond. There are everything is here, sir. So we can find its homo-lumo gap. This is, sir, sigma. This is pi.
Okay.
Yes, sir. Thank you, sir. Sir, this is the IR of my ligand L1. Yes, sir. Sir, this peak. Sir, first of all, I want to explain that this is before 1500. This is the range of 1500. This side, this is fingerprint region, and this is, sir, functional group region. Okay. So these all are stretching vibration, because bending vibration we can't consider in IR diagram. Okay, sir. Then, sir, this shows presence of NH. Sir, this shows the presence of oxygen. And sir, this is at 16 to 1700, sir, since this have amide, sir. Yes, sir. Since this have amide, presence of amide, C double bond O N. So this is not only carbonyl, this is amide. So we can see its IR peak on 1722. And these all are CH, OH, and other things are. Yes, sir. This is the IR of ligand number 2. Yes, sir. Only benzene change, sir. This is, we can show also here NH, presence of NH, O, and this is, sir, C double bond O. So this is the IR of nickel metal complex of HL2. So this, here we can see that the metal is completely bind with ligand. 13 CNMR of ligand L1, sir. Yes, sir. This is ligand L1, and this is its NMR. 13 CNMR. Okay, sir. And it's the bonding diagram. Here in this figure, it can bond with metal and make a complex. This is the molecular structure of ligand L1. This is the molecular structure of ligand L2, and this is molecular electrostatic position potential of ligand L1. So this is important for us that we can show that different hydrogen have similarity. So we found that all hydrogen have green in color, all sir carbon are in yellow in color, and sir these nitrogens are red in color. These are nitrogen which are red in color, sir. This is in molecular electrostatic potential of ligand L2. Sir, this is biological activity. As we see, sir, we tried so many antibacterial activity against E. coli and antifungal activity against S. aureus. Sir, we found that fungal activity of S. aureus in human body. This is the fungal of activity of S. aureus on human body, because this bacteria is grow a colony in human blood. This is human blood, and the growth of S. aureus bacteria in human blood, as we seen. So, sir, I tested on my compounds that yes, sir, my compounds are effective on this against E. coli, Escherichia coli, and against S. aureus. Yes, sir. So we can found different complexes, and this is MIC, minimum inhibition, minimum inhibitory concentration applied. FMIC, that means applied minimum inhibitory concentration. It is a crucial measurement in assessing antibacterial activity of substances. Sir, when we found L1A, as we noted, sir, this we found FMIC at 200. Sir, not effective at 100 milligram concentration, 50, 10, 1. This is totally useless at this concentration. This shows no any type of effect. It starts affecting at 100 microgram per ml, and it works very good on 200 and 500 microgram per ml concentration. So this is our
You
next.
tried only in E. coli or other bacteria also?
No, sir, we take two bacteria only, E. coli and S. aureus. We took only two bacteria, sir, because sir, this is very difficult for me, because no access is provided to me in Dr. Hari Singh God lab. They provided only these two bacteria, because they said that other bacteria are very difficult and very dangerous. So you proceed with these two bacteria only, and after PhD you can work on different bacteria also, because they did not allow me to enter the lab, sir.
Okay.
Okay, sir. So synthesis characterized of ligand L4 acetyl benz D imidazole 2 yl imino 3 benzyl thio 6 methyl 1,2,4 triazine 5 4H on HL3 with some metal complexes. So same we use the metal benzimidazole. This is methyl, and in next ligand we use benzene. Yes, sir. So these are its CHNS sample, and it's almost proven the compound presence. So these are CHNS data. Its color magnetic moment, sir, diamagnetic to paramagnetic. Everything explained, sir. Sir, IR data of L3. Sir, once again you can see, sir, presence of ammonia, presence of NH, and sir, presence of sir carbonyl. Yes, sir. Yes, sir. Sir, bonding in complex. Huh, sir?
Proceed.
Yes, sir. Sir, these are our new compound synthesis of characterization of ligand. So these are my new compound. E41H benzo D imidazole 2-yl ethylidene amino 3 benzothioid 6 methyl 1,2,4 triazine 5,4H on HL dash. I represent HL dash, and by taking, yes, sir. Yes, sir, there is simple gap. Yes, sir, this is methyl and this is benzene. This is the major gap between these two ligands, and we find its CHN sampling. So it's IR. So in this sample of ligand L1, so there is water is present. The IR is perfect according to engineers, but the
But
water is present in excess by
these
mistake.
peaks are too broad.
Yes, sir.
Peak is too broad.
Sir, I can't hear. Sorry, sir.
The peak is too broad.
Symbols here. 1, 2, 3.
The spectrum is
Okay. Yes, sir. Sir, yes, sir.
compound is not pure.
Yeah, sir. Sir, this is sir. Yes, this is due to sir water and presence of hydrogen bonding, sir. This becomes a broad peak, sir. Yeah. But the next peak is very good, sir. There is the presence of yes, sir. This is ligand L double dash. Sir, bonding in ligand. This is structure. And sir, what goal I set after my PhD? Sir, during my PhD, I learned a lot about characterization process, thesis writing, seminars, and presentation. Due to some internal issues, I got my CSIR fellowship in my 4th year. It affects severely my research work, but now after my PhD, I am planning for MTech from IIT Delhi on the behalf of GATE score. So by doing MTech, I want to learn about material science and applications of chemicals with industrial point of view. I also liked very much to teach students. So after MTech, I will try to do my best to join a good university to teach students and make them qualify CSIR, JRF, NET, GATE, TIFAD exams, and will also try to start a chemical manufacturing unit. It's my plan, sir, after my PhD, because I want to join, sir, IIT Delhi for next further MTech. Okay, sir. And thank you, sir. Sir, over to you, sir. Anybody want to ask any question to me? Oh, okay, sir. Any questions, sir? कैमरा कैमरा आप कर दीजिए, कैमरा सामने कर दीजिए ना, कैमरा यहाँ कर दीजिए.
Any questions from audience?
Hello, sir. Ashish Puskar this side.
Pardon?
Am I audible?
Yes.
Hello. Hello.
Proceed.
Ashish Puskar this side. And I want to ask a question. Why did you focus over peaks in the range of above 1500 per centimeter? Why don't you focus on peaks under 15 per centimeter, 1500 per centimeter? Why it is over 1500 per centimeter only? Thank you. I'm satisfied. Thank you.
Okay, sir is satisfied. Hello, sir. Is satisfied, sir? Right. Okay.
Yes, sir,
Thank you, sir.
satisfied.
Any questions from anybody? Why have you selected this topic as your research? Okay, thanks. Uh, you have defended yes, very nicely. And if you of the best of your life, I again I am again thankful to all our yes, all our all, yes. Arun sir, I want to take your permission and sir, sir, yes, so, sir, are you satisfied with this? Sir, if you are satisfied, then I want question. Hello, sir.
Hello?
Yes. If you are satisfied, then
I am able to hear you.
yes, yes, yes. Yes. Hello, sir. Hello. Are you hearing, sir?
Bhagat sir, I
Hello.
will suggest you to connect by your computer only.
Please hide up.
PhD thesis presentation successfully, sir, with your permission. कॉल फ्री ले लें कट जाएगा दोबारा कनेक्ट हो जाएंगे सर ठीक है
Now you are audible. Siddharth
यस
sir,
सर
now you are
यस सर
audible.
यस सर 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 आप इससे एक बार इससे पूछ लीजिए सर सर यहाँ से कनेक्टेड है उनका आवाज ये तो हमको सुनाई पड़ रहा है हाँ वो सुनाई दे रहा है सर लगे कम लगे
Hello, sir.
Hello?
Sir, I am Dr. Shailendra, HOD of this Department of Chemistry, Patna University.
Sir.
Sir, I welcome you. And are you satisfied with this PhD Viva-Voce examination?
Yes, yes, yes.
Very, very much thankful, sir. And can we Sir, please give permission to finish this PhD Viva-Voce
Yes,
examination.
you can.
Yo, okay. Thank you, sir. Thank you. Okay, sir. Thank you.
Thank you very much. Thank you very much.
Congratulations.
Hearty congratulations, Professor D.N. Thakur Sahab.
Thakur sir.
Thakur Sahab,
D.N. Thakur, sir.
hearty congratulations. Hearty congratulations, Thakur Sahab. And also, congratulations to the candidate, Premanand Kumar Bhagat. Thank you.
Thank you, dear Dr. D. Ashok sir. Many thankful to you, sir.
अरे माइक को थोड़ा दूर हटाइए.
Congratulations.
ठीक है, हटा दे इसको. ये सर हुए नहीं. हो जाए सर डिस्कनेक्ट हम. तुम करिए.
Sir, first, you have to send the report, sir. First. Please talk to it.
हम सबमिट दें.
कैमरा ऑफ कीजिए. पलक निकाल दी.
सर को बधाई दीजिए.